Alright, good morning everyone. Sorry I can't be there today. My son is running a fever, so I had to stay home with him. Now, what this lesson is today, that you guys are going to be watching and taking your notes on, is over the last conic section, which is the hyperbola. Now, everything we're going to talk about with the hyperbola is very, very, very similar to the ellipse in terms of the equation, the h, the k, the a, the b, everything like that. There's a whole bunch of similarities, but there's also so many subtle differences that there can be some confusion that sets in terms of the formulas. Now, let's start off. You don't have to take any of these notes that I have on here, okay? I just kind of want to look at these two things that I have here, the hyperbolas and the ellipses, and just look at some similarities and differences, and then we'll jump over to the notes, and I'll fill out that outline that you have on paper in front of you. So, first of all, look at what hyperbola is. I'm going to circle this hyperbola in blue. A hyperbola, if you want to think about it, is not exactly two parabolas that face opposite each other, but if you want to think of a good visual, that's what it is. It's two parabolas that face away from each other, but they're not actually parabolas, but that's the best way to think about it. And you can have horizontal hyperbolas, like the one I just circled in blue, or you can have vertical hyperbolas, like this one I just circled in red, depending on which way they open. Just like you can have horizontal ellipses and vertical ellipses. If you have a hyperbola, there's also parts to the hyperbola. And again, you don't need to label these, just kind of look. Just like with all the others, we have a center point right there in the middle. A hyperbola has two vertex points that I'm highlighting here in blue. And they also have two foci, which are out somewhere in the middle of the hyperbola. So it has a center, it has two vertices, and it has foci, just like with the ellipse. There's also something called a transverse axis, which is the segment that connects the two vertices. That red segment I just drew is called the transverse axis, and it connects the vertices of the hyperbola. That's the transverse axis. Okay. Now, I want you to look at the equations of the hyperbola versus the ellipse. The ellipse equations are below, and these are the ones we've talked about before, and I want you to notice the key differences. And some of your eyes are probably starting to see some differences, and so I'm going to point them out. The biggest difference is in the ellipse, your squared quantities are being added. But in the hyperbola, they're being subtracted. So one of the biggest differences is in the equation, it's a minus sign instead of a plus. In an ellipse, the way you know the direction of the ellipse is by where the a value is. A is always the bigger number in the ellipse. And that's how you determine which way the ellipse is going to be. But in the hyperbola, notice that the a value comes first both times. So in the hyperbola, a could be the bigger number, a could be the smaller number. A and b are kind of irrelevant. What matters in the hyperbola is which letter comes first. If you notice in the horizontal hyperbola, the very first one, notice the x term comes first. And that's what makes it a horizontal hyperbola. But in the second one, the y term comes first, and that's what makes it vertical. So in the ellipse, it's the bigger number that matters. In the hyperbola, it's which letter comes first that matters in terms of if it's horizontal or vertical. The next difference is in the ellipse, you know that ABC relationship with the foci, how it was a squared minus b squared equals c squared? That was the relationship for the ellipse. In the hyperbola, it's actually the Pythagorean theorem. It's a squared plus b squared equals c squared. Right there. So what I want to do now is jump to the notes, and I'll kind of rewrite this stuff, but I'll put it so that you guys can write it down as well. And then we'll just do those examples. So I'm going to jump to the next slide. Okay. We're not going to worry about the definition right now. I don't want to worry about that. But I do want to talk about the formulas that I just mentioned right there above. So for a horizontal, I want to jot this down. For a horizontal hyperbola, it's going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. That's the horizontal hyperbola. In the vertical, it's going to be y minus k squared, so now the y is going to come first, over a squared. Notice a squared comes first in both cases, minus x minus h squared over b squared equals 1. And then the relationship that you guys need to know is a squared plus b squared equals c squared. Okay, so now we're going to kind of put this into action and just kind of see how we use all this. So we're going to actually do example 2 first. I think this will help us get some understanding if we do example 2 to begin with. All right. So I look at this equation, and immediately I know it's going to be a hyperbola. Notice it doesn't say draw the graph of the hyperbola. It says draw the graph of this equation. And one thing you guys are going to have to be able to do is determine what type of graph it's going to be based on the equation. I see x squared and y squared, and I see they're being subtracted. So I know I'm going to have a hyperbola. So here's how we graph a hyperbola. The first thing we want to do is identify the center. Just like in the ellipse and in the circle, the center is h comma k. So it's going to be the opposites of those numbers in the parentheses. So it'd be negative 2 comma 5. And we're going to plot that over here, negative 2, 5. Right. All right. The next thing is think about what direction this hyperbola is going to open. It's going to be horizontal because x comes first. All right. And just like in the ellipse, the next thing I want to do is identify a and b. And we haven't talked about what you do with a and b with a hyperbola yet, but it's similar to the ellipse. Well, I know a squared comes first, so 16 is a squared, which means a is 4. I know a is 4, and I know b is 5. And here's what we do with these. Just like we did with the ellipse, since the a is underneath the x, we are going to go right and left 4 units. 1, 2, 3, 4, put a point. 1, 2, 3, 4, put a point. These are vertex points. Those are vertex points, because I know my hyperbola is opening sideways. Those are vertices. Now, what I do with the b value, I go up and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. Those are not vertices, but I want to explain this. This is where it starts to get a little different, so I'm going to kind of do this slowly so you understand. With the ellipse, remember we would just take those 4 points and just sketch the oval. Well, this is not an ellipse, so it's a little different. Here's what we do with this. I'll just draw this, and then hopefully you remember. So we're going to draw a little reference rectangle, and it's going to look something like this. I'm going to dash it. Basically, those 4 points we just plotted become the midpoints of this rectangle that I'm drawing right here. And the rectangle is going to make a little more sense here in a second. So I drew that rectangle, all right? And notice that those 4 points from A and B are the midpoints of that rectangle. The rationale of the rectangle is this. A hyperbola is going to extend, and it's going to snuggle up to slant asymptotes. If you guys remember slant asymptotes, and we use this reference rectangle to create those slant asymptotes. What we do is we take these corner points, and we draw a line and connect those corner points. That red line right there is a slant asymptote. You'll see what I mean in a second. And then I connect the other 2 corner points. Right there. Those 2 red lines are the slant asymptotes for the hyperbola. Nothing I've drawn other than the vertices are actually on the graph of the hyperbola. But we use everything we just did to sketch the graph. Because right now I can graph it, and here's how. So we said the hyperbola is going to be horizontal, and it's going to snuggle up to those red lines at the ends of the coordinate plane, and it's going to go through the vertex that we plotted. So what we do, I like to start up at the top here, and kind of bring it down towards the vertex, hit the vertex, and then snuggle towards the other slant asymptote. So that's one branch of the hyperbola. And then you do it to the other side. Start at the top, close to the slant asymptote, hit the vertex, and then go down to the other one. And we just graphed our hyperbola. So we used A and B to create that reference rectangle. We connected the corners to get the slant asymptotes, and then we drew the graph. The next couple of things I want to do is identify the focal points. I want to figure out where are the foci. And so now, just like we did with the ellipse, in every problem, you're pretty much going to be using that a squared plus b squared equals c squared relationship. Well, I know a squared is 16. I know b squared is 25. That means c squared equals 41. And when I square root that, I get c to be plus or minus radical 41. Remember, C, just like in the ellipse, C is the distance from the center to the focal points. So from the center, negative 2, 5, we're going to go right and left radical 41, which is about 6.4, I think, yesterday. So from the center, go right, 1, 2, 3, 4, 5, 6.4, put a point, and go left about 6.4. And there are the focal points right there. But I want to state the coordinates of those focal points. Oops. No. Okay, the coordinates of the foci. Remember, your foci are stated from the center. And from the center, negative 2, 5, you're going right and left radical 41. So the coordinates of the foci, notice the y value stays the same. The y value is still 5. But the x value, you're going to add and subtract radical 41. So your coordinates would be negative 2 plus or minus radical 41, comma 5. The last thing you might be asked to do, it's probably the easiest thing to do, but you might be asked to find the slopes of the slant asymptote. Slopes of the asymptotes. And all you do to find the slopes of the slant asymptotes is count rise over run. Think back to 6th grade when you learned how to count. We're going to count from the center point up to this corner point, and that's going to get us the slope. So from the center to the corner, we go up 1, 2, 3, 4, 5, over 1, 2, 3, 4. So the slope of that upwards one is 5/4. The other one's always going to be the same number, but negative. So they're going to be plus or minus 5/4. And that just gives you an idea of how wide or how steep your hyperbolas are. Smaller that number, like if it was 1/3 or 1/2, then the narrower your hyperbola is going to be. All right, and that's how we graph it. We're going to jump up to number 1. All right. It says write an equation with foci at 6, 0 and negative 6, 0 if the length of the transverse axis is 8. Well, the first thing, and you guys know to do this, plot those foci. Plot points at 6, 0, negative 6, 0. Those are the foci. Then it says the length of the transverse axis is 8. And I mentioned this, but just to refresh your memories, the transverse axis connects the vertices. It goes through the center and connects the vertices. Well, when they tell you the focal points, they actually tell you what the center is as well, because the center is right in the middle. So the center of this hyperbola is at 0, 0. I know that's the center. And so the transverse axis goes through the center and connects the vertex points. That means from the center we can actually go right and left 4 units. 1, 2, 3, 4. And that's where our vertices are going to be. Because if we connect that segment, that would be our transverse axis, and that's 8 units long. So there's our vertex points. Okay. I know this hyperbola is going to be sideways, right? Because everything's going horizontally. And so I'm just going to start to plug in the information I know. Since it's sideways, I know I'm going to have x first, and I know the x coordinate is 0. So I'm going to have x squared over something minus y squared over something equals 1. Here's what I know so far. But I have to find those somethings, and that's what a squared and b squared are. So now let's think about this. A is the distance from center to vertex point. So a, in this case, would be 4, which means a squared is 16. That's what goes under the x squared. Now, I don't know what b is. I don't know what b squared is. But I do know what the c value is. The c value is from center to focal point. The c value is 6. So if a is 4 and c is 6, we can find b squared. That's what we're looking for. I just noticed up above, I put a squared plus b equals c squared. I just saw that. There. Fixed it. You guys probably thought I was stupid. Alright. So we know a squared is 16. We're going to use the a squared plus b squared equals c squared. A squared is 16. I don't know b squared. But I know c squared is 36. So b squared is 20. This particular problem doesn't say to graph, it just says write the equation. The graph is just there to give you some reference, but we're looking for b squared and we found it. So fill it in. There's our equation. Right there. Alright, let's go to the next one. We've got 2 more. So the next one says write the equation of the hyperbola. So they give you a graph. Now we need the equation. Well, let's look. Always identify the center if you can. The center is at -4, 1. Okay. So what that means is I can start to plug in some information here. I also know the hyperbola is vertical, which means the y is going to come first. So it's going to be y minus 1. Notice I keep the y value with the y squared over something, minus x plus 4 squared over something equals 1. And now I have to find the a squared and b squared. Well, a is from center to vertex. So a is this right here that I'm highlighting. So a is 3. So if a is 3, a squared is 9. And a squared always goes first. Well, I don't know b, but I know c. I know c is 5, which means I can find b squared. So it's a squared plus b squared equals c squared. 9 plus b squared equals 25. Subtract 9. B squared equals 16. And that's what we're looking for. Right there. So notice the a value in this case is smaller. And the y comes first. Okay, last one. And then you guys get to practice on your own. It says, find the center, vertices, foci, and asymptotes, then graph the hyperbola. Okay. They give us this messy looking equation here. We've dealt with this before. You should look at this and think, well, we got to get that into hyperbola form, which means we need to complete the square. We got to group the x's and y's. So 25x squared plus 100x minus 4y squared plus 24y equals 36. Now, completing the square only works when a is 1, when the number in front of your squared term is 1. And in both cases here, in both groups, there's numbers in front of the squared terms. So we actually have to factor those out first. So for the x group, we're going to pull out a 25. And we have x squared plus 4x. Leave some space. For the y group, be careful here, because we don't pull out 4, we actually pull out -4. And when you do that, when you pull out -4, that's going to flip the signs here. It's going to make you have y squared minus 6y. So be careful there. A lot of mistakes are made there. Equals 36. So now we need to complete the square. So in the x group, we're going to take half of 4 and square it. We get 4. And remember, to the other side, we don't add 4. We actually multiply 25 and 4 together. We add 100. For the y group, half of 6 squared is 9, so we're going to add 9. But we need to multiply -4 and 9 together. We get -36. Alright, so we're getting there. So now we are going to do a couple things. We're going to factor our groups. X plus 2 squared minus 4, y minus 3 squared. And then over here we're going to get 100. Now remember, your equation has to equal 1. So from here, you need to divide everything by 100. And then we need to reduce our coefficients here. So 25 over 100 is 1/4. So we're going to have x plus 2 squared over 4 minus 4 over 100 is 25. So y minus 3 squared over 25 equals 1. So we finally got it into the form that we need. Okay. So now we need to actually answer all the questions. So the center is going to be at -2, 3. I'm going to plot that. Let's see. This particular hyperbola is sideways because the x comes first. Now it's going to be sideways. We have to identify our a and b values. In this particular problem, a is 2 and b is 5. And so from the center, we're going to go right and left 2, and those are going to be the vertices. And we go up and down 5. And remember what we do with these points. We don't draw the diamond, we don't connect the dots, but we draw that rectangle. These 4 points are the midpoints of the reference rectangle. So I'm going to do this in blue so you kind of stand out a little bit. There you go. And we use this reference rectangle to create slant asymptotes. So we connect the corner points now. Right there. Those are our slant asymptotes. And for this problem, it's sideways, which means we are going to snuggle up to the left and the right. Hit the vertex, come back down. For the other one, start at the top, hit the vertex, come back down. So there's the hyperbola. Let's see, it says find the vertices. Well, we plotted them, but let's go ahead and state them since the problem says that. So the vertices are going to be at 0, 3 and -4, 3. The foci, okay, so this is now, we need to find the foci, so the a squared plus b squared equals c squared. So a squared is 4, b squared is 25, equals c squared. So c squared equals 29. So c equals plus or minus square root of 29, which is about, I don't even know, 5.4-ish. So from the center, go right and left about 5.4. 1, 2, 3, 4, 5.4. 1, 2, 3, 4, 5.4. And there are your focal points. But I want to state those ordered pairs. So the foci from the center point, we're going left and right, so we're changing the x value. It's going to be -2 plus or minus square root of 29. Oops. Comma 3. And then lastly it says asymptotes. And all they mean by that is the slopes of them, the slopes of those slant asymptotes. And so the slopes, we're going to count, remember, to find the slopes of those slanted blue lines. So from the center to corner, it's up 1, 2, 3, 4, 5 over 2. So it'd be plus or minus 5 halves. Hooray! Now you guys go ahead and get to practice. You guys have a worksheet on Canvas. That'll be due Tuesday. Happy Friday. Have a good weekend.